Okay, we are going to take the second portion of the quiz. It's pretty easy, but I just want to go over a few things with you. Make sure you're okay with it. So, we're going to talk about normal CDF. And how we get to normal CDF is we go second bars. And then we're also going to talk about inverse norm. Okay? So, number 2 and number 3 on our calculator. So this is how the calculator will find you the area without you having to go to an actual table in order to do it. So, normal CDF is when you have 3 scenarios. If you had like less than a number, more than or greater than a number, or between 2 numbers. Okay? This requires 4 things. So, if we had for normal CDF, if we knew a score and a standard deviation written like this, and we wanted to know that if you score lower than a 20, how often would this happen? So this is going to go into normal CDF. So we're going to use normal CDF, and I'm going to plug in a few values. I'm going to plug in, being I want lower, this is the area under the curve this way. So I don't have to go 1 minus. Okay? So if I wanted to score lower than that, I'm going to take my lowest limit. So you have to think about this one being a couple of standard deviations to the left. Now some people might say, hey, we want to plug, negative 100 in. That's pretty far down. If you think about how standard deviations go, we have the average, we have the standard deviation. So if I go left 1 standard deviation, I get to 25. If I go left more, I get to 20. If I go left 1 more, I get to 15. I go left 1 more. I mean, you're going really small. So if I made my lower limit, in this case 0, it's actually going to be the same as if I made my lower limit 5, because, as you're that many standard deviations down. So then I'm going to plug in the score that I want, 20, and then my mean or my average, and then my standard deviation. So this is going to plug into normal CDF on the calculator, and this is going to allow you to see what percent would that happen. So if I go to my calculator, do this, I'm going to go to, just make sure we have it all down. I'm going to go to second bars. I'm going to go to normal CDF, and I'm going to plug in 0, 20, 30, 5. And if I do that, this gives me an answer of 0.0227, or 2.27% of the area is to the left. So what's the chance that I would score lower than 20 on this particular test? 2.27% of the time. Okay? Now, one thing I want you to see is, remember when I said this number here, I could have changed it to 5 or even 10. I mean, as you go more and more standard deviations to the left or to the right, you're talking about a smaller and smaller area. So if I take the exact same problem and I change my lower limit to 5, you're going to notice that only a small portion of the answer, so 0.0227, well, way out here is where it starts to change. Okay, even if I changed that 5, make it a 9, make it a 9. So we're just talking about even if I changed this, I mean, because we're so many standard deviations away, 0.0227 is pretty much the same. It's just as I get closer and closer to getting to one of those standard deviations, my later number decimals will change. Okay, so that's going to be if we had a value less than. Now, if we said more than, so let's take the exact same scenario. What if I were to score higher than 27? Okay, so this is an area like this. 27, 30 is my mean. So I'm going to be like talking about this kind of area under the curve. So I'm going to the right. So if you use the table in the back, you're going to have to find the area and then go 1 minus whatever that area is. Or your graphing calculator is going to use normal CDF again, and I'm going to do this. So my lower limit here is going to be 27. My upper limit, being that my average is 30 and my standard deviation is 5, we can go 3 standard deviations to the right or more. So I'm going to make my upper limit like 50. Okay, that's definitely outside the realm. My average is still 30 and my standard deviation is still 5. So this is going to give me the area from the right on over. And again, a lot of times people will say, well, let's make that like 1,000,000. Okay, the further you go out to the right, the less that decimal is really going to change. And you're only worried about the first 3 or 4 digits of the decimal. So could I change it from 27 to 50, 27 to 100, 27 to 1,000? What's the right way to do it? You have to look at what your average is and what your standard deviation. And if you go out to 50, 35 is 1 standard deviation, 40 is 2, 45 is 3, 50 is 4 standard deviations away. Totally enough to do that. Excuse me. And so let's plug that in. So I'm going to go second bars, normal CDF. Okay, I'm going to plug the 27 in. That's my lower limit. Comma 50 is my upper limit, or 55 or 100 or whatever. And then 30 comma 5 for my mean of that. Close the parentheses, hit enter. So what do I do? So what's the chance that I score higher than a 27 on this test or this game or whatever? 72.57% of the time. It's very likely you will score higher than a 27 on this test. Okay? And then the last one is, what if we wanted to know a range of scores? So what if I wanted to know, could I score higher than, I don't know, 18, but lower than, I don't know, 35. Okay, so this kind of scenario is, I'm talking about the area in between 2 points. So higher than an 18, this is going to go this way, and lower than a 35, so I'm going to go this way. So we're talking about the area in between, and we're leaving off 2 tailed regions. So that's what we're finding here. So what's the chance that I score between an 18 and a 35 on this scenario? So again, it's going to be normal CDF. So second bars, normal CDF. And my lower limit is now going to be 18. My upper limit is going to be 35. My mean and my standard deviation stay as is. So the area between that is 0.833. What's the probability that I score between those scores? 83.3%. Okay? So it's pretty likely you're going to score in there. What's the probability I don't score between those scores? Anyone idea on that? 1 minus that. And if I were to say, what's the probability if they change this, is if I don't score in between those, if I don't score, it's this area and this area. So you're going to have, in order to find those areas, you're going to go 1 minus whatever your 0.833 was. and it's going to give you the probability out there. Okay, so that's normal CDF. That's the normal curve. Okay, a lot of times they're going to tell you this. This means is normal. The first number is the average or the mean, and the second number is the standard deviation. Okay. Then you have the inverse norm. And the inverse norm is they gave you the area, okay, and they want to know the score. So what they have done is they're giving you this area, and they're going to tell you what that is. Okay? Sometimes you might have to realize if I go one way or the other, if I want to score in the top 80%, and I know that I have a normally distributed item, and I'm going to go with my 30 and my 5. Okay? Top 80% is from here over. So let's change 80% to a decimal. 80% as a decimal is what? 0.8. So we're going to convert this to 0.8. And then I'm going to plug into my inverse norm. And the inverse norm is going to go this way. 0.8 comma my average comma my standard deviation. And that's going to tell us what this score would be in this scenario. So if you're like, you know what, I just want to do better than, I want to do in the top 80%. So I only want 20% of the population to do less than me. So on your calculator, I'm no longer going to use normal CDF. I'm giving the area. I'm going to go with inverse norm, which is number 3, and I'm going to plug in my values. I have 0.8 or 0.80, comma 30, comma 5. Okay, and if I do this, this is going to tell me what score I would have had to score to do better, to be in the top 80%. So I would have to score, I'd have to score a 34 on the test in order to fall into that region. Okay? Now, the only other thing to think about on this scenario is what happens if I said, I want you to fall in the, I goofed this up. I goofed it up, I could save it. Okay. If I wanted to fall in the top 80%, how many people did worse than me? What percent did worse than me? If I wanted to fall in the top 80%, how much did worse than me? Okay, so I have to realize I'm actually going to use 0.2, and that's going to refer to this. I just need to change my inverse norm. I got to change that 0.8 to what? 0.2. So, I'm sorry, I goofed up. If I want to do better, I need to score 25.8 or better to be in the top 80%. If I wanted to score in the top 10%, you're talking about 90% of the population. So things you want to think about. So I goofed up on this. Make sure if we're going to be top 80%, we're talking about doing better than the 0.2, only 0.2 less did worse than us. So that should help you on this quiz. Okay, so inverse norm, you're looking to solve that value, what score you would need to get. Top 10% means you would probably plug 0.90 in. Bottom 30%, you're still plugging 0.3 in for bottom 30%. If you are trying to find the area or the probability, you're doing normal CDF. If you're trying to find the score from the percent or from the area, inverse norm. Got it? So that's going to help you on this. So it's a really tiny, itty-bitty quiz.